They called it famine food, emergency ration, the protein you ate when nothing else remained. Modern nutritional databases confirm it contains more protein per gram than beef when measured by dry weight, requires no refrigeration, grows in soil that kills wheat, and can be stored for decades without spoiling. Yet today, suggesting it as a primary protein source triggers the same social response as admitting financial collapse. This reclassification was not accidental. What ancient empires built on? Modern economies buried. Mesopotamian administrative tablets from 2400 BCE record lentil distributions as standard military rations, not crisis supplies. Sumerian soldiers received daily lentil portions calculated by weight and marching distance. These were not substitutes for meat. They were the foundation. Babylonian temple records show lentil cultivation occupied more irrigated land than barley in certain provinces. Egyptian tomb paintings depict lentil harvests with the same ceremonial importance as grain. Workers who built the pyramids received lentil paste as a primary protein source, documented in ration lists preserved in desert sand. This was not deprivation, it was infrastructure. The protein density of dried lentils reaches 26 grams per 100 grams, matching cooked beef gram for gram, but lentils achieve this without the energy cost of animal husbandry, without the land requirements of grazing, and without the water consumption that makes cattle ranching possible only in regions with abundant rainfall or irrigation. Roman legions carried chickpeas as standard field rations during campaigns that lasted years. Military manuals specified preparation methods, storage protocols, and daily quantities per soldier. When Titus besieged Jerusalem in 70 CE, Roman supply lines delivered chickpeas and lentils in quantities that matched wheat shipments. These were not emergency foods. They were strategic assets. The Roman agricultural writer Columella described fava bean cultivation as essential to soil fertility and troop nutrition, dedicating entire chapters to rotation schedules that maintained both land productivity and protein availability. Legume cultivation was not marginal farming. It was imperial policy. Roman soldiers consumed approximately 850 grams of grain and 200 grams of legumes daily during active campaigns, a ratio that provided complete amino acid profiles without requiring meat. The logistics of empire depended on foods that did not spoil, did not require fuel to preserve, and could be transported across thousands of miles without loss. Meat was a luxury when available. Legumes were the constant. Andean civilizations stored quinoa and tarwi beans in colca complexes engineered for multi-decade preservation. Inca administrators tracked legume stores with quipu knot systems that recorded protein reserves across thousands of miles. These storage networks were not famine preparations. They were the backbone of an empire that fed millions without animal agriculture as Europeans understood it. Chinese dynastic records describe mung bean and soybean cultivation as fundamental to feeding armies and cities, with fermentation techniques that transformed these proteins into forms that required no cooking fuel. This knowledge was not primitive. It was sophisticated resource management. The Han Dynasty maintained grain and legume reserves sufficient to feed entire provinces for 3 years, a strategic depth that allowed the empire to survive droughts, floods, and wars without mass starvation. The technology was not complex. It was discipline. Lentils require 43 gallons of water per pound of protein. Beef requires 1,800 gallons. Chickpeas fix nitrogen in soil, eliminating fertilizer dependence and improving yields of subsequent crop. Cattle require external feed inputs that consume more plant protein than they produce in meat. A family storing 200 pounds of dried lentils secures a year of protein in a space smaller than a closet, with no energy cost and no spoilage risk. The same protein in beef requires industrial refrigeration, continuous power, and consumption within days. This is not opinion. This is thermodynamic. 1 acre of land produces 375 pounds of beef protein annually, assuming optimal grazing conditions and supplemental feed. The same acre produces 2,000 pounds of lentil protein with no external inputs beyond water. The efficiency gap is not marginal. It is structural. Beef production generates 27 kilograms of carbon dioxide equivalent per kilogram of protein. Lentils generate 0.9 kilograms. The environmental cost is not comparable. It is exponential. The Great Famine in Ireland between 1845 and 1852 killed over 1 million people, while the island exported beef, pork, and grain to England. During the worst year of the famine, 1847, Ireland exported 4,000 cattle, 3,000 pigs, and over 800,000 quarters of grain. Lentils and fava beans grew in Irish soil before the potato blight. They were classified as peasant food beneath the economic system that prioritized export commodities over local nutrition. When the potato crop collapsed, the infrastructure to produce and distribute alternative proteins had been systematically dismantled. People starved within sight of fertile land because the economic classification of food had replaced its biological function. The famine was not a crop failure. It was a system failure. British officials documented the exports in parliamentary records while simultaneously describing the Irish population as dependent on relief. The contradiction was not hidden. It was policy. During the siege of Leningrad, from 1941 to 1944, over 800,000 civilians died of starvation. Soviet records show that military supply lines prioritized meat for frontline troops, while urban populations received reduced rations. Legumes, which could have been stockpiled in quantities sufficient to prevent mass death, were not distributed at scale because the logistics system was designed around perishable animal products. The siege revealed that modern food systems optimized for normal conditions collapse entirely under disruption. Survival required the foods that empires had built on, but those foods had been reclassified out of strategic importance. The Soviet Union had the agricultural capacity to produce legumes in vast quantities. The failure was not in production. It was in the assumption that modern supply chains would never break. When they did, the backup systems did not exist because the foods that required no supply chain had been removed from strategic planning. 1 acre of land produces 375 pounds of beef protein or 2,000 pounds of lentil protein. Beef production generates 27 kilograms of CO2 equivalent per kilogram of protein. Lentils generate 0.9 kilograms. Government subsidies in the United States allocate $38 billion annually to animal agriculture, including direct payments, feed crop subsidies, and infrastructure support. Legume crops receive less than 2% of that support. This economic structure is not based on nutritional efficiency. It is based on a system that emerged after World War II, when industrial meat production became a marker of economic development and geopolitical power. The reclassification of legumes as famine food occurred during the same period that meat consumption became a policy goal. In 1950, average American meat consumption was 144 pounds per person annually. By 1970, it reached 194 pounds. The increase was not driven by nutritional need. It was driven by subsidies that made meat artificially affordable and marketing campaigns that associated meat with prosperity. Modern nutritional science confirms what ancient civilizations practiced. Lentils contain 26% protein by dry weight. Beef contains 26% protein by cooked weight, but only after energy-intensive production. Chickpeas provide complete amino acid profiles when combined with grains, a pairing that appears in every major ancient cuisine. Fava beans contain compounds that enhance gut bacteria diversity, a discovery that validates millennia of traditional preparation methods. The scientific validation arrived centuries after the knowledge was marginalized. The data did not change. The classification did. Research published in peer-reviewed journals now documents what Roman military manuals described. Legumes combined with grains provide all essential amino acids in ratios that meet human nutritional requirements without animal product. The discovery was not new. It was a rediscovery of what had been systematically forgotten. The same pattern appears across food systems. Amaranth was a staple grain of the Aztec Empire, banned by Spanish colonizers because its use in religious ceremonies threatened Catholic conversion efforts. The ban was not nutritional. It was ideological. Quinoa fed the Inca Empire, later classified as Indian food and excluded from modern agriculture until Western markets rebranded it as a superfood in the 21st century. The nutritional content did not change. The market classification did. Millet sustained African civilizations for thousands of years. now categorized as birdseed in industrialized nations, despite containing more protein than rice and requiring less water than wheat. Teff, the foundation of Ethiopian nutrition, remains largely unknown outside its region of origin, despite containing more protein and calcium than wheat. Each of these foods was not replaced by superior alternatives. They were buried by systems that prioritized different economic structures. The pattern repeats because the mechanism is consistent. Foods that enable self-sufficiency are reclassified as inferior when centralized food systems require dependence. Climate models project that regions currently producing beef will face water scarcity and heat stress that make cattle ranching unsustainable within 30 years. The American Southwest, the Australian interior, and regions of sub-Saharan Africa already show declining cattle productivity due to temperature increases and water shortages. Legume crops thrive in the same conditions that kill livestock. Drought-resistant varieties of chickpeas and lentils already exist, developed by research institutions, preparing for climate scenarios that governments have not yet acknowledged in food policy. When water becomes the limiting factor in agriculture, the foods classified as famine rations will be the only proteins that scale. This is not prediction. This is hydraulic inevitability. Beef production requires 15,000 liters of water per kilogram. Lentils require 2,000 liters. When water is rationed, the choice is not ideological. It is mathematical. The return is already beginning, not through policy, but through collapse. Regions facing water restrictions see beef prices rise beyond affordability, while legume consumption increases by necessity, not choice. The language shifts slowly. What was called famine food becomes plant-based protein. What was called poverty food becomes sustainable nutrition. The biological reality never changed. Only the economic pressure required to overcome the classification. In California, water restrictions have forced ranchers to reduce cattle herds by 20% since 2020. In the same period, chickpea cultivation increased by 35%. The shift was not driven by environmental awareness. It was driven by water costs that made cattle ranching unprofitable. The market did not choose sustainability. It responded to scarcity. The reclassification extends beyond nutrition into language itself. The term famine food does not describe the food. It describes the economic status of the people who eat it. Lentils do not become less nutritious when consumed by the wealthy, but they are rebranded as plant-based protein or sustainable nutrition to remove the association with poverty. The food is identical. The classification changes based on who consumes it and under what economic conditions. This linguistic pattern reveals the mechanism. Food is not classified by its biological function, but by its position within economic hierarchies. When those hierarchies collapse, the classifications collapse with them, and the foods that sustained empires return to their original function. History does not repeat by chance. It repeats because the systems that create vulnerability are never dismantled, only renamed. The same subsidies that made meat artificially cheap now make it artificially scarce as climate change disrupts the water and land required for cattle ranching. The same economic structures that reclassified legumes as famine food now scramble to rebrand them as the solution to food security. The solution was never lost. It was buried, and it is returning not because it was rediscovered, but because the conditions that allowed its burial are ending. If this vault revealed something they tried to bury, subscribe to preserve what history erased. Knowledge survives only when it is remembered. The next vault opens soon.